अच्छा होगा,
हम्म।
तो मतलब बाकी एग्जाम्स का थोड़ा ज्यादा डर है।
वो चक दे मूवी देखी है?
हाँ हाँ।
उसमें वो शाहरुख खान बोलता है ना सारे प्लेयर्स को, पहले हम इंडिया के लिए खेलना है, फिर जान बच जाए तो स्टेट के लिए खेलना है, और फिर थोड़ी बहुत जान बच जाए तो अपने लिए खेलना है। तो यहाँ पे सबसे पहले क्वेश्चन पेपर प्रिपेयर करना है, फिर जान बच जाए तो तुमको असाइनमेंट करना है, और फिर जान बच जाए देन यू हैव टू डू एनी अदर थिंग। सो योर मेन थिंग इज योर क्वेश्चन पेपर एंड असाइनमेंट। कूल। यू गाइस मस्ट बी टायर्ड। और हमारे हमारे यहाँ तो सीन भी हो गया था, हमारा पेपर ऑलमोस्ट 35 मिनट्स लेट आया। और और हुआ ये कि सुमैया को और मेरे सिस्टर को पेपर दे दिया like after that 35 minutes, and rest of us didn't get it, so we had to wait another few minutes। और फिर लास्ट में जो सब लोग चला गया, और लास्ट में जो टीचर थे वो बहुत खड़ूस थे, बोल रहे थे कि अरे तुम लोग को टाइम में क्या जरूरत है, कितना लिखोगे, 6 बजे तक लिखोगे क्या? तो उन लोग सबने आर्ग्यू किया। फिर उनको बोला गया कि आपकी कंप्लेन होगी, तब जाके वो शांत हुए, नहीं तो वो बोल रहे थे कि पहले ही खत्म करके चले जाओ।
अच्छा।
या
ओ,
सो
थोड़ी बहुत ज्यादा
सॉरी
हुआ।
क्या?
35 मिनट्स बहुत ज्यादा हो गया।
I know, we were like tired sitting, just sitting on that stupid bench. और बेंच भी इतनी
For
ऐसी
whole hours.
uncomfortable होती है ना। Yeah, we are used to sitting on comfortable chairs, and if you give us those, the school kids होते हैं ना, वो जो
स्कूल
नर्सरी में
वाले।
जाते हैं, वो इतना पतला वाला चेयर, तो you are like literally hanging from the chair। Yeah।
हमारे सेंटर पे सो जब 40 मिनट्स बचे थे, देन विजिलेटर वाज लाइक 10 मिनट्स बचा है, तो व्हाटएवर द
हम्म।
टाइम वाज ही वाज लाइक ऑलवेज सेइंग इट 10 मिनट्स कम करके, लाइक 30 मिनट्स बचा है तो 20 मिनट्स बचा है। तो
Because
मतलब
they want to go home early, right?
एग्जैक्टली दैट इज सो स्टूपिड। लाइक व्हाई, लाइक
हम्म।
नहीं, लास्ट के 5 मिनट्स तो पेपर कलेक्शन है, लाइक क्यों पेपर कलेक्शन जब हमारे पास
हम्म।
3 घंटे टाइम है ना। टू आवर्स
हम्म।
55 मिनट्स नहीं है टाइम, पेपर कलेक्शन हद
हाँ,
होती है।
एक्चुअली ये आदत हम ही ने खराब की है, क्योंकि हम में से कुछ स्टूडेंट हैं जो जल्दी पेपर करके निकल जाते हैं ना, तो वो लोग सोचते होंगे कि यार इग्नू में क्या है, पढ़ते वढ़ते तो है नहीं लोग, थोड़ा बहुत पढ़ा आ गए, कितना लिखेंगे। सो वो उनका वो बन गया है, दे बिकॉज वो ऑब्जर्व करते होंगे ना स्टूडेंट्स को कि कितनी देर में स्टूडेंट्स जाते हैं। सो उनको लगता है कि हाँ अरे यार, इतना लिखना नहीं होता है, बट जो पढ़ के गया है उसको समझ में आएगा ना कि कितना लिखना है।
हाँ।
मतलब आई couldn't really finish all the आंसर्स। मेरा लास्ट में मुझे छोटे छोटे आंसर्स लिखने पड़े, बिकॉज मेरे पास स्पेस ही नहीं बचा हुआ था। आई हैड टाइम बट आई
सेम
डिडंट हैव
सेम।
स्पेस। तो वैसा सीन हो गया। हाउ वाज योर पेपर, आशीष? आशीष, आई कांट हियर यू, मे बी ऑन म्यूट। ओके, लेट्स टॉक टू सज्जन। सज्जन, हाउ वाज योर्स?
अरे बढ़िया था।
अच्छा था।
अरे बहुत, जितना पढ़ा है वो सही है, सही आया।
वेरी
और असाइनमेंट्स करना चाहिए था, और जो लास्ट लास्ट ईयर के पेपर से वो देखा, बहुत सही हुआ यार, मतलब
करेक्ट।
वेरी गुड। और थैंक्स गॉड
करेक्ट।
कि हम
और
लोग वो जो 2 सेशन में हमने किया वो बहुत हेल्पफुल था,
हाँ
लास्ट
जी,
2
कल
सेशन।
वाला स्पेशली, कल, हाँ कल का और परसों का ऑफ कोर्स। तो मैंने बोला ना, जिसने जिसने कल का सेशन अटेंड किया है वो दे विल बी हैप्पी। और मूवी वाला लिखा कि नहीं एग्जाम्पल लॉकिंग में?
हाँ हाँ।
लिख दिया ना, छाप दिया?
तो क्या।
ओके, वेरी गुड।
मुझे याद भी आता है, इमरान ने बोला था ये बात में।
वेरी गुड, वेरी गुड। यही होता है, मतलब व्हेन यू डिस्कस एंड लर्न, मजा भी आता है, और प्लस वो दिमाग में चीज रहती भी है। मुझे भी काफी सारे पॉइंट्स थे, एंड आई कुड रिमेम्बर दोस पॉइंट्स बिकॉज सम ऑफ देम कृतिका हैज सेड। कृतिका की स्टोरीज मुझे याद थी, व्हाट व्हेन करके मैंने लिख दिया था उधर। ठीक है,
सेम
सुमैया।
सेम सेम, मैंने भी वही सोच के लिखा, व्हाट व्हेन व्हाई, इसका एग्जांपल।
यस, सुमैया के कुछ पॉइंटर्स थे, तो वो यूज कर लिया था जब उसने चीजें
हेलो।
समझाई थी तो। हाँ आशीष।
बट बट एज आई नो, सौम्या इज वेरी सैड बिकॉज नॉर्मल फॉर्म ज्यादा आया नहीं।
एक आया था क्वेश्चन, उसमें से नॉर्मल फॉर्म, कभी कभी ज्यादा भी आ जाते हैं, बट ठीक है, हमने काफी प्रिपेयर किया था, उसमें आ गया। यस आशीष, क्या वी कैन हियर यू, हाउ वाज योर पेपर? उसका कुछ इशू चल रहा है लगता है। एक और बंदा ज्वाइन करने की कोशिश कर रहा है बट उसका भी माइक का इशू है। सो
अच्छा
या अपना
इमरान, जस्ट
ग्रुप
मुझे पूछना था इसलिए इसके बारे में कि वो डीएसए का और जावा का दोनों का मैच
हेलो।
सेम पीपीटी है क्या अटैच करके, या फिर डीएसए के लिए अलग पीपीटी प्रिपरेशन किया है?
मतलब अटैच नहीं किया
हमारा
मैंने, जो
नहीं, हमारा
अलग अलग है।
डीएसए सब, हम डीएसए का मैंने मुझे एक्सेस चाहिए था
हेलो।
उसके पीपीटी का।
हाँ मैं दे देता हूँ एक्सेस।
हेलो
मैं अपना ईमेल
इमरान,
आईडी।
हाँ
कैन यू am I audible? Ashish here.
यस यस यू ऑडिबल।
Wow. So thank you, Imran. First of all, I would like to thank you, and I love you always, man.
I would say you have to thank all of us because it was a team effort, not just me
actually,
alone.
and
Yeah.
thanks to Kritika for providing that one answer for data mining and warehousing, correct?
डेटा माइनिंग डेटा वेयर हाउस, मेरे पीछे वाला मुझसे पूछ रहा था कि डेटा माइनिंग क्या होता है, मैंने कहा अपना लिखो तेरे को बैठ के आंसर करूं। मेरे को पूछ रहा डेटा माइनिंग क्या होता है, मैंने कहा जा कृतिका को पूछ बैंगलोर में।
मेरे मेरे सज्जन मेरे बाजू में ही बैठा था ना, सज्जन और हम लोग
सच
दोनों
में
अच्छा खासा हमने डिस्कस करके क्या सब कुछ।
सजन तुम झूठ मत बोलो।
अरे तो क्या कितना ऐसा बोल रहे जैसे कि
ये अच्छा
मजाक।
सज्जन कैसा था, अच्छा था ना?
अरे अच्छा था।
लाइक रिवीजन भी अच्छा हुआ और पेपर भी हम लोगों ने जो सोचा था उसके एक्सपेक्टेशंस के 110% नजदीक ही आया है।
हम्म। अरे अपने व्हाट्सएप ग्रुप के बारे में सबको नहीं पता है एक्चुअली। पुणे में काफी लोग थे, मेरे पीछे बंदा जो बैठा था वो भी उस ग्रुप में नहीं है, ही डिडंट इवन नो अबाउट इट। तो या आई थिंक नॉट एवरीवन नोज अबाउट द ग्रुप। दिस इज पहले बना था ना, काफी टाइम पहले ये ग्रुप।
हाँ, लास्ट फर्स्ट सेमेस्टर में ही बना हुआ था।
हम्म।
तो
ओके गुड। सो मैं, हाउ वाज योर पेपर?
It was great. I did everything.
वेरी गुड वेरी गुड। ठीक है, सो अभी अपने पास 6 दिन है इंक्लूडिंग टुडे, और अपने पास 2 पेपर है जो बैक टू बैक है। तो हम सिर्फ पहले फोकस करेंगे कि विल जस्ट डू द असाइनमेंट एंड द क्वेश्चन पेपर्स। ठीक है, हम वही करेंगे, और हमने वो स्लाइड्स को ब्लू मार्क किया हुआ ऑलरेडी। तो इफ यू गो टू दोस स्लाइड्स यू विल बी एबल टू सी कि वो इंपॉर्टेंट वाली वो ब्लू स्लाइड्स है। तो वी विल मेक श्योर कि वी आर कंफर्टेबल विद दोज आंसर्स फर्स्ट, और उसके बाद अगर कहीं टाइम बच जाता है देन वी विल डू द रेस्ट ऑफ द क्वेश्चंस। तो जावा वाला तो हमने बहुत तैयार किया हुआ है, काफी टाइम से जावा का क्लासेस चल रहे हैं, बट या वी विल प्रॉब्ली स्पेंड लेस लेस टाइम ऑन जावा इनिशियली एंड स्पेंड मोर टाइम ऑन डेटा स्ट्रक्चर एंड एल्गोरिथम, क्योंकि उसमें बिल्कुल भी टाइम स्पेंड नहीं किया। और आगे चल के व्हेन वी आर कॉन्फिडेंट अबाउट आशीष, ओके, व्हेन वी आर कॉन्फिडेंट अबाउट द algorithms, then we will probably spend equal time on both.
So today are we doing Java or DSA?
We'll do half an hour of Java, and then the rest of the time जब तक हमारे पास energy होती है, maybe till 10:30, we'll do algorithms, data structure algorithm, DSA. ठीक है, so
कल संडे
let
है, बिफोर वी स्टार्ट इमरान, लाइक कल संडे है तो कल चाहिए तो 2 सेशन रख सकते हैं अगर आज थोड़ा जल्दी खत्म करना हो तो।
हाँ ठीक है, मतलब हम ट्राई करेंगे एटलीस्ट थोड़ा पढ़ाई तो हो जाए। बिकॉज सीन क्या है ना कि इट्स नॉट अबाउट हाउ मेनी टाइम्स यू स्टडी इन अ डे, इट्स अबाउट हाउ मेनी डेज यू रिवाइज दैट। क्योंकि हमारी जो लॉन्ग टर्म मेमोरी होती है ना, वो उसमें स्टोर हो जाता है। अभी आज तुम कुछ पढ़ोगे वो लॉन्ग टर्म मेमोरी में जाएगा, नेक्स्ट दिन तुम फिर से पढ़ोगे तो वो और स्ट्रांग होता जाता है वो चीज। The more the number of days you spend on revising those things, better you will get. मैंने उसमें काफी सारी चीजें पढ़ी थी काफी टाइम पहले, बट बिकॉज वी वर रिवाइजिंग दोज एवरी डे, वो चीजें एकदम जबान पे थी। So because everybody is tired today, we'll try to wrap it up as quick as possible. But yeah, we'll spend good enough time today, and then tomorrow we can keep it. Everybody's comfortable for a 6 p.m.
या फाइन।
Is anyone who not okay with the 6 p.m.? Okay, so I'm assuming everybody is good with 6 p.m. So we'll do 6 to 8, and then from next week onwards we can do it like 8 p.m. or something, 8 to 10. ठीक है?
ओके।
So I'm gonna share my screen and start. Rajan, would you like to mute? थैंक्स। ये लोग पहले एक्सेस मांग रहे हैं, इनको एक्सेस देते हैं। सज्जन, कौन सा एक्सेस तेरे पास नहीं है? डीएसए का एक्सेस नहीं है ना?
Yes, DSA.
So let me share that with you. सज्जन, और एक और कौन है? आशीष।
Ashish. Yeah.
ओके, तो I'll share that with you guys. और जावा का तो है ना सबके पास?
Yeah, oops,
Yes.
no, object oriented. Yeah, we have.
ओके, ठीक है। So let's start. Share the screen.
Hi Imran, this is Anirudh. Can you hear me?
Hi Anirudh, yeah, how are you?
Yes,
I'm
Anirudh.
good.
You
I
can.
joined for the first time. Can you
Yes.
share the access with me also?
Yeah, I will do that. No
I'll just
problem.
share my email ID.
Okay, I'll do that like after this session. Okay.
Sure, no problem.
Thanks. Okay, so we'll start with the Java. Again, we'll only gonna do the last year question paper and the assignments. So all the blue sides that you see. We'll first get comfortable with these. Okay, so first we talk about the object and classes. So object is nothing but a real world entity that can be distinctly identified. An object is an instance of a class that has properties and methods. Class is a template or a blueprint that defines data fields, which are member data or instance variables, and methods, which are also called member functions, objects of the same data type. Okay, so what is object? It's a real world entity that can be distinctly identified. It's an instance of a class having properties and methods. These properties are also called member data or instance variables, and the methods are also called member functions. Okay, moving on. How the object is created? This is an important question. So object is created in the following steps. One is declaration. A variable is declared with the variable name and an object type, and then instantiation, where we allocate the required space to the object using new operator. So this is the first step. There's a object type, and that's the variable name. And in the first step, we declare the reference to the object. In step 2, we use the new keyword, name of the class, round brackets, and we assign it to this variable that we have created. And this is the place where the memory is allocated. This is where the reference of the object is created. Generally, we can also combine these two steps into one and put it like this. So in the first step, only a reference to a variable or an object is created. At this stage, no actual object exists. So the key thing to remember from this is that at the first step, a reference to the object is created. Object does not exist. No object exists. Okay. When a new operator is used, then the memory is allocated. Then the object exists. Initially, in the first step, what happens? The reference to the object is created, but not the object itself, just the reference. And in the second step, where then you use the new operator like so, then the memory is allocated, and then the object exists. The new operator in Java is used for dynamically allocating memory for an object. It returns a reference to the object and also binds the reference with the object. Okay, let's move on to the next one. Then we have data hiding and how it is achieved. Data hiding enables developers to protect their data and hide implementation details from the outside world. To implement the data hiding, variables in a class should have private access modifiers. So when someone needs to access or modify private variables from outside of the class, they should be able to access it by using get and modify it using set. So in simple words, data hiding means protecting the data by hiding the implementation details. Okay, and how we do that in a class? If we declare any variable as private, then it cannot be accessed by the outside world. Even if you create a child class, you cannot access that. The only condition you can access it if you create getters and setters. So private variables can only be accessed within the same class. However, it is possible to access them if we provide public get and set methods. The get method returns the variable value and set method sets the value. Then we can use those methods get name and set name to access the value of the private variable. Okay, so let's take an example. So we have a class called person, and like we said, to implement data hiding, we declare a variable as private. Okay, so this is an access modifier. Now, if we try to access this inside an object of this class, if we try to get the value of that object, my object.name, you'll get an error. If you try to set the value, you'll get an error. But if we use get name and set name, so for example, if you define a getter which returns the value of this private variable, because inside of this class you can access this variable but not outside. So this function is going to return name because it can access it, and this function is going to set the value of name by taking that as a parameter. So then you can go ahead and use it using set name, and just get name will print that particular object value. Okay, I want somebody else to read it. So let's see, whom do we have new? Anirudh, was you able to read?
Yeah, I think so.
Okay. So let's read this.
So advantages of abstract class with the help of a program. Abstract classes are a way of organizing a program. Grouping classes together is important in keeping a program organized and understandable. So what I understand from abstract classes is basically uh, they are like usually a parent class, and there are child classes which can extend the abstract class, and they can implement the abstract methods which are not implemented in the abstract class itself.
Yeah, right. And what are the
So
advantages?
I'm not 100% sure about the advantages.
This is what the advantage is. So they are a way of organizing a program, and grouping the classes together is important in keeping a program organized and understandable.
Okay, so
Yeah.
okay, got it.
So abstract class you can consider like, let's say I'm supposed to do a set of work, but I don't want to do it
Mhm.
now. I'll do it later. I just want to define it and keep it ready. That's what's happening
Okay.
right now. If you notice, this method is not implemented. There's nothing inside of the method. It's like,
Mm-hmm.
if I want to do a homework, I'm going to put the question number, I'm going to leave some space, and I'll do it later. I'll probably do that for 5 questions. Okay, so just keep it
Okay.
ready. We'll do it later. So this will give you kind of a, you can think of it like a blueprint, that
Mm-hmm.
this is what's supposed to happen.
Okay.
Okay, so you can extend it, but if you extend it, you will have to implement those classes like so.
Yeah.
So it's a way of organizing the program. Let me highlight that. A way of organizing a program, and grouping classes together is important. Grouping classes is important in keeping the program organized. Okay, go on.
Okay. Yeah, the advantage of using an abstract class is that you can group several related classes together as siblings. So I think several classes which extend the base class, they can be treated as siblings, I guess.
Yeah.
Okay. Abstract classes provide you the flexibility to have certain concrete methods and some other methods that the derived classes should implement. So I think in
Yes.
abstract classes there are two types of methods: abstract methods and concrete methods. Abstract
Mm-hmm.
methods are just declared; they are implemented in the child classes, and there
Mm-hmm.
are concrete methods which are implemented itself in the abstract class itself.
Hmm. Okay. Advantage of using an abstract is that you can group several classes together as siblings, provide you flexibility to have certain concrete method and some other methods. Cool. We already looked at the example, so we'll skip that and move on to the next slide. Okay. Thanks, Kritika, for coloring that blue. It's really helpful.
Okay, polymorphism and its advantages. Polymorphism is derived from a Greek word poly and morph. The word poly means many and morph means forms. So it means many forms basically.
Yeah.
Polymorphism is the ability of an object to take many forms.
Mhm.
It allows one interface to be used for a general class of actions. Polymorphism principle is implemented in Java programming with methods overriding and overloading and overriding.
Yep.
So overloading allows methods that perform similar closely related functions to be accessed through a common name. I think the method name is same and the number of arguments or argument type is different in overloading.
Correct.
Overriding works together with inheritance to enable code reuse of existing classes without the need of decompilation. So basically, when there is a base class and child class,
Mhm.
and there is a method in the base class, then child class can override that method basically.
Correct. Make it do something else.
Yeah, to provide their own implementation.
Excellent. Uh, where are you located?
I am also in Pune,
Oh, excellent. Which part of Pune?
in Yerwada actually, in Pune Nagar.
Okay. I used to work in Yerwada in Tech Mahindra.
Oh, cool.
Yeah, in front of Yerwada jail, there is a whole, what is it called? What
Yeah,
IT park? Commerce IT park. I don't know.
Commerce
It's
Zone
some
IT Park. I live
Commerce Zone. Yeah,
quite near
Commerce
to
Zone.
that. Yeah.
Yes. Yeah, I worked there for almost 4 to 5 years.
Oh, great. Where are you located now, by the way?
Right now I'm in Undri.
Okay.
Cool. So polymorphism means, I mean, literal meaning is poly, which is many, and morph means forms. Its ability to make for an object to take many forms and allows one interface to be used for a general class of actions. Polymorphism is implemented with the methods overloading and overriding. Overloading allows methods that perform similar or closely related function to be accessed through a name, which means calling the function multiple times. Each time could be with different parameters. And overriding is like uh, calling this, I mean, redeclaring the same function and making it do something else. Some of the advantages are tends to reduce the pairing of multiple functionalities and allows programmer to reuse, evaluate, execute the program modules forms written once. Types of polymorphism. Ashish, can you read this?
Yeah. So the static polymorphism, it is
Uh-huh.
the linking of function with an object during compile time. It is
Hmm.
achieved through the method overloading. In overloading, method uses the same name but the with the different
Parameters.
parameter. I guess there's,
Hmm.
the sentence is not correct here, but with different the parameter instead of
Yeah, yeah,
it should
it's
be like,
incorrect. You're right.
but
Let's correct it.
okay.
Okay.
So dynamic polymorphism. In this, the compiler doesn't determine the method to be executed. It's a Java virtual machine that performs the process at the runtime. It is achieved through the method overriding.
All right. So two types of polymorphism: static and dynamic. Static is the linking of the function with an object. When does this happen? It happens at compile time, achieved through overloading. And dynamic polymorphism, compiler doesn't determine the method to be executed. The JVM that performs the process at runtime. So static polymorphism happens at compile time, and dynamic happens at runtime. So there is a question in the question paper. Whenever you see double star, it means it's in the question paper, and possibly in the assignment also. But if you see just a single star, it means it's just in the assignment. So the question paper says, explain how polymorphism helps in the code reuse in Java programming with the help of a program. So overloading, go ahead, Ashish.
So the overloading allows different method to have the same name but different signature, where the signature can differ by number of input parameters or the type of input parameters or both.
Excellent. So in this example, as you can see, the same function sum is been defined multiple times, but each time with a different data type, different set of parameters, and each time it's called with different set of parameters. So you're overloading same function to basically using different signatures each time. And we discussed that overloading is related to the compile time and overriding is related to the runtime polymorphism. So moving on, I love to skip the slides. Okay, Kritika?
Yes. Use of super keyword in Java.
Yeah.
The super keyword refers to superclass or parent objects. It is used to call superclass methods and to access the superclass or parent constructor. It is used to eliminate the confusion between superclasses and subclasses that have methods with the same name.
So a parent class is also called a superclass, and a child class is also called subclass. What happens is that if the parent class and the child class have the function with the same name, like in this case, animal sound exists both in parent and the child. It could be confusing for the compiler if you call that function with that name, because it would not understand whose method I'm supposed to call. Am I supposed to call the parent method or the child method? So that is why if you prefix it with super dot, then compiler will understand, okay, so I'm supposed to call the parent method. So if you call it with a super dot animal sound, it'll be the parent will be called, and if you just call the animal sound, then the child will be called. Okay, moving on.
Imran, this is an inheritance only, correct?
Sorry.
Like the super is used in inheritance only.
Yes, it is used in inheritance. That's right. Okay, Kritika.
Yes. Use of static method in Java. The static keyword is used to construct methods that will exist regardless of whether or not any instances of the class are generated. Any method that uses the static keyword is referred to as the static method. Static methods have access to class variables or static variables without using the class's object or instance.
Right. So a simple thing to remember is that if you declare anything, any method with static, then you don't really have to instantiate that particular class. You can access that method into another class without having to instantiate it. So, like in this example, you have a class called student, and it has a static variable. It has a static method called change. If you try to access change here in another class, you are able to do that, is because it's declared as static, and you didn't have to do new. New is when you use new. We have discussed that you are instantiating the class and you are able to access the methods. But here you are able to access change method without having to instantiate it. Okay. Yep. Explain why main method in Java is always static. So thanks, Sumaya, for this one. Yeah, Ritika, go on.
The static is a keyword which we use in the main method to define it as static. There is no object of the class available at the time of starting Java runtime, and because of that, we have to define the main method as static. By doing that, JVM can load the class into the main memory and call the main method.
Okay, so let me explain that to you. So notice that every function in Java, not every function, but the main function in Java, always has to be declared public static, right? So we are not focusing on a public right now. We are focusing on the static right now. So they're asking why main function is we have to define static. Why can't we remove this? And the reason for this is because this function is called before the class is instantiated. So if I go ahead and not declare it as, we already established that you can call a function that is static without instantiating the class. So if we don't do that, then it won't be able to call this function, because it'll say, okay, you have to first instantiate this class, then by using new keyword, then only I'll be able to call this method. And this method is automatically called when the class is instantiated. So at this stage, it is not instantiated. So we have to declare it as static, and that's what is explained over here. Let's see what this is. Yeah, so this is the error method you're going to get. So if you create a function main, and if you skip this, if you forget adding static, this is the error you're going to get. Main method not found in the class test main. Please define main method as public static void main. JavaFX class must extend or blah blah blah. Okay, so you'll get an error. Okay, moving on. Okay, write a Java program which takes 3 numbers as input and displays the largest among these. So whenever we want to take an input from the user in Java, we have to use the scanner class. And scanner class is present in the Java util class, package. So we import that, and then we create our own class called max numbers, and you can name it whatever you want. And inside of the main function, we instantiate this scanner class and hold it in a object. And we already learned how to create an object in one line. So that's what's happening here. So this will be object, and there's a requirement that you're supposed to pass system.in. This will allow it to read the input from the keyboard. This will it'll allow us to take the input from the user. Okay, so we create the scanner object using the scanner class. Then we declare a variable called max integer.min value. So min value is a constant in Java, which will give you like the minimum value that you can compare against. So there are certain constants that are available which will help us to write some programs and do comparison, like max value, min value, when you want to find some largest or smallest numbers. So now we're going to loop through it 3 times. Then we're going to ask the user for entering the number. Since you want 3 numbers, rather than writing this 3 times, we just use it in a loop. So automatically we run 3 times. Then scanner object, which is basically of this class, has a method called nextInt. So when we call that, is going to read the input, whatever user enters, like he enters 0, is going to read that input from the keyboard and hold that value inside of input. Now, over here, the variable that we created, max, we're going to set it equal to if whatever user has entered is greater than the max value, which we are storing here, then the value will be input, otherwise the value will be max. And we keep doing that for all 3 numbers, and eventually we will have the maximum number inside of this variable. And once this loop finishes, we're just going to print in and provide the value of this max, and then we have to close the scanner object using the close function, because we don't want any more input after that. So that's the program, and that's part of the question paper. So in question paper this time in Java, we have to write some of programs also. Okay, let's move on. Wow, I can skip so many slides. I like it. Okay, Sumaya.
Yeah, data types in Java. Primitive data types. The primitive data types include boolean, char, byte, short, int, long, float, and double.
Okay.
Non-primitive data types. The non-primitive data types include classes, interfaces, and arrays.
Okay.
Primitive data type boolean has default value false, its size is 1 bit. Char has default value this, and its default size is 2 bytes. Byte is 1 byte. Short is 2 bytes. Int is 4 bytes. Long is 8 bytes, float is 4 bytes, and double is 8 bytes.
So boolean is 1, char is 2, byte is 1, short is 2, int is 4, long 8, float 4, double 8. Okay. Boolean 1, character 2, byte 1,
Boolean is
short.
1 bit.
Sorry?
Boolean
Boolean
is
1
1
bit, yeah.
bit.
Correct. Int 4 byte, long 8, float 4, double 8. Okay, excellent. I think this slide also should be in colored because it's part of that question. I don't know what more we can write in the data types. Yeah, we can explain non-primitive ones. Again, this is also part of that. So let's change the background. Okay, go on.
Non-primitive data types. Classes. A class is a template or blueprint from which objects are created. It has properties and methods. Interfaces. An interface in Java is a blueprint of a class. It has static constants and abstract methods. It is used to achieve abstraction. By interface, we can support the functionality of multiple inheritance. It can be used to achieve loose coupling.
Right. So a class is a blueprint through which multiple objects can be created. How you have cookie cutters. So cookie cutter you can consider as a class, and with the help of cookie cutter you can create multiple cookies, which of the same shape and size. So those cookies are your objects. So it's like a blueprint with the help of which you can create similar projects with the same design. Similarly, interface is a blueprint of a class, and one of the key things that it helps you achieve is abstraction and multiple inheritance, which is not supported by default in Java.
What does loose coupling mean?
Loose coupling, even I don't know. We have to check. It means classes are independent of each other. The only knowledge one class has about the other class is what the other class is exposed through its interface in loose coupling. If a situation requires object to be used from outside, it is termed. If a situation requires objects to be used from outside, is termed as loose coupling situation. So the only knowledge one class has about the other class is what the other class is exposed through its interface in loose coupling. So in loose coupling, it's saying that classes are independent of each other. They don't know what is there inside of the other class, except the one they are share, except the things that they are actually sharing. So if they're sharing any particular instance variables, or if they're sharing any methods, only that information is available in other class. Otherwise, they are independent of each other. That's what the loose coupling means. Let me put that. The only knowledge one class about the other is what the other explores through interfaces. Okay, moving on. We still have non-primitive data types. We're still doing that. So this will also be full slide. And after this, we'll stop and we'll after this one, we'll stop and we'll move on to DSA. Okay, cool. Okay. Yeah, let's finish this off. Carry on, Sumaya.
Arrays. Array is an object which contains elements of a similar data type. Additionally, the elements of an array are stored in a contiguous memory location. we can store only the fixed size of elements in the array. It doesn't grow its size at runtime.
So it's the same definition we learned in C programming, which is arrays are the elements of the same data type and they are stored in a contiguous memory location. Same definition you can write. Just need to learn how they are created. So int a equals new int 5, so it's a size 5, and then you're just initializing them by storing values inside of each of the index, and you're just printing them. Okay.
Single dimensional array, a list of variables of similar or same data type. We can access values using index.
Okay, so we declare an array called mynum, and here we are directly assigning the value, which is 10, 20, 30, and 40. So, and then in this situation, we have cars, which is equal to this, and we can print the first item, so we can access by index. Okay, we'll stop here, and then we'll move on to the data structures and algorithms.
So Imran, one question.
Yeah.
Like, what is the basic difference between primitive and non-primitive data types? Is there an, like, what is the
Uh,
significance?
Primitive and non-primitive data type, I would say. Let's find out.
What I searched, it shows like primitive data types are predefined and non-primitives are user or programmer defined.
Yeah, yeah, yeah. That's correct.
But from that, I think array and string should also come under primitive, but it's an exception, I guess.
I'll leave this question to you. I want you to
Sure,
find out and let me know. Okay,
sure, sure.
in the next class, or you can also paste it in the group also if you like.
Okay.
In Java, I think non-primitive data types are pointers. They're
Pointers don't
stored
exist
as
in Java, do they?
references.
No, they
They're
don't exist in Java.
implicit pointers.
Where?
You don't explicitly have pointers. So those objects are pointed to an address in memory.
Okay, fine. Maybe one person, Anirudh, you can spend some time and let us know
Yeah,
what you
I
come up.
will post it in the group.
Okay, awesome. But good, I'm glad you guys are asking questions because that's how we learn together. And when you, especially any time you discuss, consider that as getting registered in your memory, like your program registers. It just gets registered, and most probably you'll not forget it. So the more you discuss, the better you get. Okay, so we are doing the DSA, which is data structures and algorithms. This is the first time we're doing this. We could have covered the basics also, because but we don't really have the time, and we don't want to spend time in learning the basics right now because we have limited number of days. In this 6 days that we have to do both. We have to do Java also, and we have to do DSA also. Don't think that that after giving. So what day is Java, by the way? Is it on the Friday?
It's
Does
on
anyone know?
Saturday.
Saturday. Okay. So don't think that if you haven't studied Java in one night, which is on Friday after you give exam of DSA, you will be able to learn and give exam. So we have to do it every day. We have to spend some time for both. So then one night before the exam, we want to just relax, not worry too much. Cool. So there's a question in question paper called time complexity and space complexity. So if you take a look at the question paper here, time complexity and space complexity, what is the difference between the two? And this is a question that is asked in a lot of interviews as well. If you ask me, data structures and algorithm are very, very important when it comes to when you're applying for jobs or competitive exams. They'll ask you a lot of questions based on time complexity, space complexity of an algorithm. It's a very, very useful topic, to be honest, and it'll always help you if you study this really, really well. Even when to write good programs, to write efficient codes. So let's go on with this. So generally, there's always more than one way to solve a problem in computer science with different algorithms. For example, if I give the same question to all of you, then and ask you, give you like half an hour, uh, then everybody will solve it, and there are high chances that none of you have a similarity of solving the same problem. Maybe each one of have some difference in the way you're solving problem, so the algorithm that you are using could be different. So that's what I was talking about, that in computer science there could be different ways of solving the same problem. Therefore it is required to use a method to compare the solution in order to judge which one is more optimal. And because the performance is really really important when you write code. So, what are those methods? One is the time complexity, and second is the space complexity. So, time complexity is an algorithm. Sorry, a complexity of an algorithm is a representation of the amount of time required by the algorithm to execute execute to completion. So, how much time, if that algorithm that one person, let's say Kritika writes, uh, how much time it's going to need to complete or to execute that particular algorithm. Okay, and then we can compare that with probably what Ashish writes and see which takes less time. Okay, so time requirements can be denoted or defined as a numeric function Tn, where Tn can be measured as a number of steps provided each step takes constant time. For example, in case of addition of two n-bit integers, n steps are taken consecutively. The total computation time is Tn equals c into n, where c is the time consumed for addition of 2 bits. Here we observe that Tn grows linearly as the input size increases. There are different notations also. I think there's big O notation which talks about the upper bound, and there is theta notation. I guess there is one more which takes care of the lower bound. So when you're using those algorithms, you can really find out that what is the time complexity of each algorithm. So let's say if you have a loop, for loop that you are running, and if you want to know what is the time complexity of that in terms of big O notation, you can say that it's on, because in case if it is going to run n times, if it's going to run just 10 times, then it's going to be linear, it's going to be always constant. So the big O notation will be o1, because it's always going to run like 10 times, it's not never going to increase. But if you use a variable, you don't know how many times it's going to run, so that's why the big O notation will be o n. Okay, so similarly, you can calculate the time complexity, and I want at least one of you to probably study this more and do a bit more explanation on these parts, how these guys work. Kritika, would you be interested in explaining this part? Maybe tomorrow.
Yes, okay.
Okay.
Alright.
So I would want an example explanation for both time complexity and space complexity. Okay.
Yes, okay.
Perfect, thanks. Space complexity, same thing, but here it's memory, is the space. So space complexity of an algorithm represents the amount of space needed by the algorithm in its life cycle. So space you can consider. So here we understood about the time, and here is your space. So for example, if you're declaring one variable, two variables, the complexity is just one. But if you're declaring that variable in a loop, so when the loop runs and loop runs n times, then it's multiplying. That variable is getting declared multiple times, so it's consuming more space compared to if it was declared outside. Space needed by an algorithm is equal to the sum of the following two components: a fixed part, a space required to store the certain data and variables, simple variables and constant and program size, etc., that are not dependent of the size of the problem. Variable part, a space required by the variables whose size is totally dependent on the size of the problem. For example, recursion, stack space, dynamic memory allocation, etc. If you are just declaring an array which is of fixed size, then it's linear. But if you are declaring a dynamic array, the size of the array can change. It can grow or it can shrink depending on the need and requirement. So at that time, of course, the space complexity will be higher because we don't know, how big it's going to grow. It depends on your program. Space complexity, which is generated as SP of any algorithm, is SP equals ASP I, where A is treated as the fixed part and SI is treated as a variable part of the algorithm, which depends on the instance characteristics. In the following is a simple example that tries to explain this concept. For example, you have a program which is sum of P and Q. We start step 1, step 2. I don't know what they're doing with this arrow here. Are P plus Q plus 10, and then you
I think
stop
this
here.
is
If
equals to this, is same as equals
equals
to
to
in algorithm. Same as equals to in
in
algorithm.
algorithm.
Yeah.
Okay, thanks. So Anirudh, have you already studied algorithm?
Not from this course, but I have some idea about algorithms.
Okay, wherever you can give your input, feel free to do that. Okay.
Sure, sure.
Okay. Here we have three variables, P, Q, and R, and one constant. Constant is 10. Anytime something is constant, we don't really have to worry about much because it's always going to be, linear. But if we have variables, then we have to check. Hence, SP 1 plus 3. Now, the space is dependent on the data types of the given constant types and variables, and it will be multiplied accordingly. Okay, so when Kritika explains these two examples, then we'll understand it better. Uh, Time
I,
complexity and space. Go ahead.
yeah, I think in this example, what
Okay, go
I
ahead.
understand is P and Q will have a variable space and 10
Yeah,
is constant space. So that's
correct.
what it's trying to say, I think.
Right. So the fixed part is 10, and the variable part is
Yeah,
P and Q, and that's
yeah,
equal to R. Okay.
yes.
Now the difference between the two, again, question in the question paper. Uh, so time complexity calculates the time needed. Space complexity calculates the memory space needed. We already studied that. This counts the time for all the statements. This counts the memory space of all the variables, even inputs and outputs. And I think it also counts the constant also.
Yes.
Depends mostly on the input data size. This depends mostly on the auxiliary variable size. More important for solution optimization, less important with modern hardwares. So what this trying to say is that our hardwares have the capacity to have big space. So if, even if you're screwing it up on space complexity, it's fine. They'll take care of that. But yeah, time complexity is definitely crucial. Time complexity of merge sort is O n log n. This is just an example. This is a big O notation, uh, and it's represented as O n log n. And it's just giving an example that if you're doing a merge sort operation, if you're writing a program with a merge sort, then that this will be the complexity. Space complexity of a merge sort is O n. Maybe one person can take these notations, big O notation, then there's theta, and there's one more. Who wants to do it? Ashish, do you want to do it?
Sorry, I'll be preparing for 202 and 203.
Oh, sorry. So yeah. I know. No problem.
Yeah, we can't.
Anirudh,
I
what
think
about
both
you?
are doing the
I
same.
can do it. Yeah, I think,
Okay, so
yeah, one
so,
is upper
so
bound,
take
one
this.
is, yeah,
Yeah, take
already.
this up. There are different notations like big O notation,
Yeah, big O,
theta notation.
lambda, and theta, I think.
Yeah, yeah. So just take those three notation, and it should be
Yeah.
from the textbook. Like those topics should be from textbook. If you want to use the content or from the internet, it's fine.
Okay.
So add that to the slide towards the end. Okay,
Okay.
wherever you think it belongs. I'll give you the access
Okay.
after this. Okay, and then you can add that there, and then probably on the next session you can explain it.
Sure.
The reason why we kind of divide the task is mainly because you when you explain something, when you teach something, you get better at it, and you can only teach something that you yourself understand, right?
Yeah,
uh,
that's
and
true.
everybody has a different way of explanation. you might be able to explain something in a better way than somebody else can. Okay, so like for example, so Maya explained normalization really well, and till exam I remembered that. It's another thing that I didn't do that question because I picked up some other ones since because of time constraint. But yeah, till now I remember what those normalization are. Kritika used those storylines, and still now I remember data mining and data. Uh, yeah, so all of those things. But so yeah, so that's why let's divide some of the work amongst us.
Okay, sure.
Cool. So moving on. Okay, so somebody has written it. I had assigned this task to somebody. So can someone tell me
I
who had
wrote
written
it.
this? Okay. Can you explain this part?
Yes. Write an algorithm to bubble sort in ascending order
So
this
first,
array.
maybe tell us what this bubble sort is actually.
Bubble sort is a sorting method in which um, you loop through the array and
Mm-hmm.
compare adjacent elements and swap
Mm-hmm.
them if they're not in order. Then after uh, each iteration, the the smallest element goes to its place in the smallest element goes to the first position in the unsorted part of the array.
Bubble sort diagram. Maybe diagram can help us. Let's take a look.
So
So
basically,
explain it. Explain it here. Yeah.
we loop through the array and we keep comparing the adjacent elements in this. So
Okay. You mean 4 and 7? Give me example here.
yeah, in this example, if I start with like this part 0, j is equal to 0, it will compare 5 and 3, and if they are not in
Uh,
order, it will swap them. So
okay.
5 and 3 are not in order, so it will swap them and it will become 3 and 5.
Yeah.
Then it will check for 5 and 1. They are also not in order. Then it will swap them again
Stop them.
and it
Awesome.
will become 1 and 5. So similarly, it keeps on doing that, and it
For
does
all the iteration.
for
Say if
all
they
the
were like,
iterations. Yeah.
so in this case, it's doing it like 7 times.
Yes. In this, for I is equal to 0, it will do 7 times. Then for I is equal to 1, it will do 6 times. And I is equal to 2, it will do 4 times.
Okay, so I'm just trying to understand why is it doing it 6 times? Like, what's the logic of using this 7? Actually, this is 7 times, right? So, what's the
So
logic of this number 7?
there are two loops here. Basically, one is
Hmm.
I and one is j. Both are
Okay.
iterating through the array, and there are two loops, one inside the other, nested loops.
Hmm.
And 7, this 6 is the size of the array. Actually, 7 is the size of the array, so that's why it's
Hmm.
going from 0 to 6. So zeroth
Okay.
iteration, it means I is equal to 0 and j is equal to 0, and
Hmm.
I 1 means I is equal to 0 and j is 1.
Understood.
So
So, loop within
so
the
on.
loop.
Yes.
So, in big O notation, this will be n square.
Yes.
Okay. So, 1, 2, 3, 4, 5, 6, 7, 8. It's showing 8 numbers. I don't know why it's taking
Yeah.
7 then.
8. Yeah, I think because we have to compare two elements, so I think the loop will run only 7 times for 8 elements because we are
Okay.
comparing two elements at one time, right?
Okay. So, that's why it's called bubble. It's like bubbling at each
Yeah,
point.
it's basically called bubble sort because as air bubbles goes to the
Hmm.
surface, and similarly, in this
Bubbles are going to the
the
edges.
maximum element tries to comes to at the end, basically like a bubble.
Okay, awesome. Awesome. Okay, cool. Yeah, Sumaya, go on.
This algorithm is slightly different than the that example. In this one,
Mhm.
the smallest element is bubble to the beginning of the array.
Okay.
Okay, so begin initialize array and array length. loop from second element to last element.
Okay.
So for I equals 1 to n, loop
Hmm.
from last element down to the current element. So you start from the last element, j equals n, down to I plus 1,
Hmm.
to the element uh, after I, after the ith
Oh,
element.
okay.
And then compare the two adjacent elements and swap them if they are not in order.
Okay.
So if array j is less than or equal to array j minus 1, swap, and that's it.
Okay. So loop through the array to the last element, starting from the second element. Loop to compare the array elements. Here we are looping from the second last element, I believe, up until I
You're
plus
looping
1.
from the
From
last
the second,
element.
That's the
it's
last
from the
element.
second element
Sorry?
till the last. It's from the second element till the last.
Second element is the last. So
And
where
minus
would it
one.
loop? Minus 1. Okay. So compare
So
two adjacent elements is going to compare the two elements, of course. Swap the elements if they are not in order using temp. Okay, cool. And then print the sorted array. All right.
I think this is overly
Overly,
complex.
if you have a
This
better
example.
example, can you create another slide and put that there? So we'll compare the two, and if you find that the other one is better,
Yeah,
then
I
we'll
think
swap it.
yeah, I will do that. I think in simpler example, the second for loop can also run from j is equal to I plus 1 to n, and
Yeah,
the rest of the thing can remain the same. Only this
yeah.
second for loop statement might change.
Okay, okay, awesome. So may if you pasted it somewhere, maybe you can put the link. It might help Anirudh to make some suggestions there. To help copy the program rather than having to write it again.
Pasted what?
Paste the link from where you got the answer.
Oh, I wrote this.
Oh, you wrote. Okay, then just maybe send it on the chat so he can use that and then modify it to make it better.
Okay. I'd
Cool.
written it the other way also, but the algorithm in the book was like this, so I changed it.
Okay, fine. Okay, now talk about stack. Sajjan, are you still there? Or your mobile dropped? Let me see. Sajjan is there, but he got dropped. Sajjan, can you hear me?
Yes, I can.
Okay, can you go over this stack?
Sure, I can read. Stack. Stack is a linear data structure that follows the LIFO, that is last in, first out principle.
Hmm.
Stack has one end, whereas the queue has two ends. It contains only one pointer, top pointer, pointing toward topmost element of stack.
Okay.
Whenever an element is added in the stack, it added on the top of the stack. An element can be deleted only from the stack.
Okay.
In other words, a stack can be defined as a container in which insertion and deletion can be done from the one end to the top of the stack.
So,
Okay.
sorry to interrupt,
Go
but
ahead.
I think the third point is slightly incorrect. So, element can be deleted only from the top of the stack.
Okay. So what's
I
wrong
think,
in this? Third one.
uh, yeah, element
Only
can be
from the
deleted
stack, it
only
should be
from the
only
top
deleted
of the
only
stack.
from the top of the stack. Yeah,
From the top
from
of the
the
stack.
Top
top
is
of stack.
missing.
From
Top
the
is
top
missing
of
here.
top. Yeah, yes.
Correct?
Okay.
Okay.
Yeah.
So stack is a linear data structure that follows last in first out principle. Stack has one end, whereas queue has two ends. Who's even talking about queue ends? Okay. So this has one end. Contains only one pointer, top pointer, one pointer, top pointer, pointing to the topmost element. Contains. Okay, whenever an element is added in a stack, added on the top of the stack, and elements can be deleted only from the top of the stack. correct?
Yeah, basically addition is also from the top and deletion is also from the top.
Okay.
So
So
one
when you
real life
push,
example can
Mhm.
be like stack of plates on top of each other. So if you want to put another plate, it will be on top. If you want to remove the plate, it will be from top.
Unless you are watching a cartoon show where you can just remove them anywhere.
Yeah. Yes.
Right. Uh, okay.
Yeah, so we can go ahead. Yeah.
So here, suppose you want to store elements in a stack. Let's assume that stack is empty. Like we have taken the stack of size 5 as shown below, which we are pushing the elements one by one until the stack becomes full. So we push the first element from the top, so it sits down. You push the second element, got pushed, and so on and so forth up until 5. If you want to remove an element, then the fifth will be removed. Why? Because it's last in, first out. So last number that was in was 5, so that's why it got removed. Then when you have 4 elements remaining, last in was 4, so 4 will be removed. On only these 3 will be left. Since our stack is full, as the size of the stack is 5, in above cases we can observe that it goes from top to bottom when we are entering the new element in the stack. Uh, so today we have entered Anirudh in our stack, right?
Exactly. But
Yes.
don't we? But we will not delete him.
Yes. If unless he wants to be deleted, so it's all up to
No.
him. I think our group study is getting popular, especially because most of the questions that we studied came in the exam. What attracted you towards the good, group study?
Yeah, I was thinking to start. I did not enroll for DBMS, so did not start before. So I just saw the message
Okay.
today or
When did
sometimes
you
like
enroll?
what
When did you enroll for it?
for the program or for
Yeah, program.
I think last year.
Okay. Okay. So you're done with the first semester, and
No,
now you're
actually I
doing the
couldn't
second.
do it. I'm just starting from scratch actually.
Okay. By the way, this is second semester, huh?
Yes, yes, I
This
know.
is, yeah. Okay. Cool. But if you can contribute, well and good. Uh, because I can see that your knowledge on the programming is pretty good, pretty solid. So you definitely can help the group.
I think I only know DSA and a little bit of Java. But yeah, I
That's all
can.
we need. We're done with the other paper. We don't need the database management system. So that's all we need. Great. Sajjan, carry on.
Yeah, sure. Operations performed on stack. The following are some common operations implemented on stack.
Mm-hmm.
Push. When we insert an element in stack, then the operation is known as a push. If the stack is full, then the overflow condition occurs.
पूरा फील से बोला तुमने ना push. Okay.
Pop. When we delete an element from stack, the operation is known as pop. If stack is empty, means that no element exists in the stack. The state is known as an unflow state.
Okay.
Is empty. It determines whether the stack is empty or not. Is full. It determines whether the stack is full or not. Peak. It returns the element at a given position. Count. It returns the total number of elements available in stack. Change. It changes the element at a given position. Display. It prints all the elements available in stack.
Okay, so I think these are all self-explanatory. These functions are really useful in most of the programming languages, even JavaScript or PHP, push, pop, and we use it all the time. And it's very self-explanatory. Push is to push the element in the stack. Pop is to delete the element, is empty, to check if it's empty or not, and all that stuff.
I
Okay,
think
go ahead.
can go back. Sorry. I think peak definition is incorrect. I think
Okay,
turns the element at the top of the stack, not at a given position. If I'm not wrong.
which one? Peak.
The
Peak.
peak, yeah.
Fourth one. Yeah. So, yeah.
Okay.
Returns the element which is present at top of stack. It is also called top, I think.
Finds the value of the field in the variable of a row that has already
No,
been loaded.
peak in stack you need to search, I think.
Okay. Is used
Top
to
of the
retrieve
stack. Yeah.
the first element of the stack or the element present at the top of the stack. So these content, of course, taken from online. So people feel free to make suggestions. You can put a comment over here if you think otherwise, and put a link also to the source of the information so we can correct it. The last thing I want to do is learn something that's probably not right. So the content that's generally taken from the Geeks for Geeks and all of these platforms. 98% of the time it'll be correct, but sometimes 2% may not be correct. Like one of the content that Sumaya suggested that secondary index was not correct online. And when I researched it, I saw that multiple places they were showing different information about the secondary index. Cool. Moving on. Okay, Sajjan, carry on.
Okay. Okay. Write algorithm to reverse a string. Approach. The idea is to create an empty stack and push all the character from the string into it. Then pop each character one by one from stack and put them back into the input string starting from the zeroth index. As we all know, stack work on the principle of first in for last out. After popping all the element and practicing them back to string, the formed string would be reversed.
Okay.
So there are, yeah, following are the steps given below to reverse a string using stack. Create an empty stack. One by one push all the character of string to stack. One by one pop all character from stack and put them back to string. Step number one is
Okay.
begin. Step number two, read string. Step number three is nlen. Step number three is initialize stack. The stack is equal to create stack. Push character onto stack for I is equal to 0 to n minus 1. Push stack ss minus I of I. Pop character from stack and put them back into string. I is equal to 0 to n minus 1. S of I is equal to pop stack. Output reverse string s. And this is the
Awesome.
algorithm for,
Awesome. I
yeah.
think it's very self-explanatory. All it's saying is that if you want to reverse it, the order, just create an empty stack, keep pushing the elements, and once it's full, then start popping out from the top. So of course, the order that you're going to get now will be reversed.
Yeah.
We'll finish today's session in 15 minutes, like at 10:30. Okay, and tomorrow's session will be at 6. It'll be nice if we have good amount of participation, because as you can clearly see, when we have more people, how this session becomes more fruitful because we are able to share each other's knowledge. Make sense?
Yeah. Yes.
Okay, go
Okay.
on.
Algorithm to insert an element into singly linked list.
Hmm.
Insertion in singly linked list at beginning. Insertion
Maybe
a new
before,
element.
yeah, maybe before we go into the algorithm, we should know what a singly linked list is. Does anyone know what this is?
Yeah.
Okay, go on.
So singly linked list is basically a data structure where there is a node
Mhm.
which has a integer value usually and a
Yeah,
pointer to the next node,
correct.
and it's represented by the head node, which is the
Mm-hmm.
first node in the list, singly linked list,
Hmm.
and then there is the value in the head node and there is a next pointer, and the same data structure is in every node of the linked list, and the
Correct.
next
Correct.
node of the last node of linked list points to null
Null.
basically. Yeah.
Right. Right. Correct. We'll look at that in detail, but yeah, that's exactly what it is. I was watching one of the tutorials from Harry. I don't know, people might have heard about him. So he was explaining that let's say there is a hospital and there are multiple beds available. One bed is in one hospital, another bed is in another hospital. So the doctor says that I'm going to operate on you, but you need to carry the address of the next bed. So he goes to the first bed, operates him, does whatever is supposed to be done, then ask him where is the address of this next bed. So he says, okay, now go to this hospital, next bed is here, got to goes to the next one. It's like a chain. Okay, so every node or bed in this case will have the data, its data, and as well as have the address of the next node on the next bed. So that's your linked list. Yep, go on,
Okay.
Sachin.
Uh, inserting a new element into a singly linked list at beginning is quite simple. We just need to make a few adjustments in the node links. There are following steps which need to be followed in order to insert a node in the list at beginning. Allot the space for the new node and store data into the data part of the code. This will be done by following statement. PRT, is not a pointer. PRT is equal to struct
PTR,
node.
PTR.
Okay, PTR.
Mhm.
Sorry, yeah, PTR is equal to struct node star malloc size of struct node star. So PTR follows to data that is equal to item. Make the link part of the new node pointing to the existing first node of the list. If this will be done by using a following statement. PTR follows next is equal to head. At last, we need to make the new node at the first node at the list. This will be done by using a following statement. Head is equal to PTR.
Yeah,
Algorithm.
algorithm.
Yeah. If PTR is equal to null, write overflow, go to step 7, end of it. Okay. Set
Yeah.
new node PTR. Yeah, it's
Okay, I thought you directly went on step 7.
no, no.
Okay, carry on.
Yeah. Set new node is equal to PTR. Set PTR is equal to PTR tends to next. Set new node tends to data is equal to well. Set new node tends to next is equal to head. Set head is equal to new node and equal to exit. Step 7. Yeah.
Okay, can anyone explain this? This looks a bit complex.
Yeah, I can try. So
Go ahead.
basically, if we want to insert a node at the beginning of simply linked list,
Uh-huh.
then basically in the usually in the beginning of the linked list is usually the head node. Now we
Correct.
have to insert a node before the head node.
Yeah.
So what we can do is we can just create a new node of the singly linked list node type,
Okay.
which is the pointer here. It's basically creating a new object or a new node, and then
Mm-hmm.
it's assigning ptr arrow data is equal to item, which is basically assigning the value to this node, the integer value which you want to assign,
Yeah.
and then it's marking the next pointer of ptr node as head. So basically we want to insert this ptr before the head, so next
Mm-hmm.
of ptr will be pointing to head.
Right.
That's what we want to do basically. So ptr next is equal to head. That's the pointer of ptr we have changed, the next pointer of ptr we have pointed it to
Right.
head now. And after that we want to update the head pointer also, because if we inserted the node at the beginning of single linked list, now this new node should become the head of the linked list, because
Correct.
now this is the
Correct.
first node. So that's why we have
Correct.
written head is equal to ptr. So now the head points to ptr. So basically if we can take example of, let's say, 1 2 and 3, 1.1 next of 1 is 2 and next of 2 is 3, and we have to insert
Mm-hmm.
0.
Mm-hmm.
Then we'll create a new node pointer and
The head
allocate a
becomes 0
memory.
instead of 1.
Yeah, head should become 0. So
Yeah.
we will create a new node of 0 with malloc. We'll assign some memory to it, and we'll
Mm-hmm.
assign the value as 0. Then we'll mark next 0 next is equal to head. So next pointer of 0 will point to 1 now, and
Mm-hmm.
after this we'll point head to 0. So head will point to
The
0
pointer
now.
that we created.
What?
Okay. Okay. The pointer that we created. We're pointing head to the pointer that we just created, the
Yes,
new
yes,
one.
exactly, exactly.
Okay. So excellent. That's a good explanation. And this is the diagram of that. So this was the old position. So this was old position. This was the first node with the pointer addressed to the next node. Another node, of course, the last one is the null. Doesn't have any pointer because there's no element after that. Now we create a new node. This contains the, of course, the data. This is a pointer. This contains the address of this first one. Originally that was first, but now it will become next. Okay, and the earlier head was the old one, which is the first, but now this new node becomes the head. So like you've explained. Brilliant. Cool. Okay, I think we have some more time. We can do one more. We can have 5 minutes. Kritika, you want to read this?
Yes, okay. What is a tree? A tree
Mm-hmm.
is one of the data structures that represent hierarchical data. A tree data structure is defined as a collection of objects or entities known as nodes that are linked together to represent or simulate hierarchy. A tree data structure is a nonlinear data structure because it does not store in a sequential manner. It is a hierarchical structure as elements in a tree are arranged in multiple levels. In the tree data structure, the topmost node is known as the root node. Each node contains
Yeah.
some data, and data can be of any type.
Hmm.
In the above tree structure, the node contains the name of the employee, so the type of the data would be a string.
Yeah.
Each node contains some data and the link or reference of other nodes that can be called children.
Okay. Before we jump on to explanation of tree, just to add to this point is that there are also a doubly linked list, and in singly linked list you just have the pointer to the next node, but in the doubly linked list you also have the pointer to the previous one as well. So you have previous and next both. So this is an easy way of remembering. Like in exam, if they ask you what is singly linked list and doubly linked list, you can explain that quickly. Okay, so I think Ritika, you were the one who explained this tree, and I remember binary tree and all of those stuff. So would you be able to explain this tree?
Yes, I'm not fully sure if it's the same thing, but I'll try.
I think
Um,
it's very similar because that also had notes and all of these things.
yeah,
You
uh,
can
but,
take a
um,
reference of the content here if you want.
but that had numbers. So basically, like if you see the second diagram,
Mm-hmm.
um,
No, it's not for. I don't think it's following a pattern, is it?
it's not following a pattern. Yes,
Okay,
I really don't know.
that's okay.
I'll
That's all right.
come prepared like another day.
No, no problem. That's completely fine.
So
Okay,
I
so you're talking.
can
Go ahead.
try.
Go ahead. Yeah, go ahead.
So basically, as it says, it's a hierarchical data structure. So basically, there is a root node usually, and there
Yep,
are
which is this one.
children, which is this one. In this case, one is the root node,
Yep,
and there are children of each node.
yep,
Like for 1, 2, and 3 are the children of 1,
yep.
and
And four,
for
five,
2,
six are for
4,
two.
5, 6 are the children. Similarly, so on and so forth. There are
Yep.
children nodes, and then there are leaf nodes. Leaf nodes are
Mm-hmm.
9, 10, and 11 here,
Mm-hmm.
which don't have any children. They are called leaf
Correct.
nodes.
Okay.
And so it's basically similar to a linked list data structure, but it can have multiple children instead of just the
Hmm.
next pointer. There can be
Hmm.
multiple children. That's a
Hmm.
tree, and in binary tree, it usually have only two children. One node can have at max two children in binary tree.
Right. Okay.
And the type of the data which is inside the tree, it can be an integer or it's string. It doesn't really matter.
In this case, this is string. The
Yeah.
names.
Yes.
Awesome. Awesome. So I think today was, we didn't think that it's going to be such a fruitful session today. And, because we also have a new addition, we that's also helpful. And we could have just chillaxed today after giving exam, but we're also keeping in mind that we have the next two exam lined up, and these 4 or 5 days gonna go like this. You never even know that. So what's important is that we be consistent in our practice, and I'm pretty sure the next two papers are also going to be rocking. I can tell you that even if you don't study or spend too much time, besides these sessions, you will still be able to score well. And the reason for that is because we cover most of the important topics here, and we do a lot of revision. So if you just consistently attend these sessions, try to involve yourself. Maybe just before the session, just read through those notes, try to understand, grasp, and participate more in this by maybe explaining, like how Anirudh or Sumaya or Kritika, all of these guys are explaining. Try to explain things. The more you involve in this, the better you'll get, and the better you'll remember things. Cool. I think that's it for today. Let's call it a night. And thanks to everyone for coming in. And let's meet tomorrow at 6.
So Imran, one question. So will
Yeah.
there be a similar session for C and Python also? Like it's not in this semester?
Because currently all of the students are in semester 2. We're already done with
Mhm.
the but
Semester
you
one.
can take reference from the previous group studies that we had. I'm going to share
Okay.
the playlist with you.
Yeah,
uh,
that would be great. Yeah.
but remember, the what we learned from the previous semester is that we were thinking they are going to give us questions from the last 10 years of question papers, and that's what we prepared. But
Mm-hmm.
it turns out that they were picking up questions mainly from the assignments and
Mm-hmm.
from the textbook itself. Okay.
Okay.
So yeah, so when you're preparing, for you it will be good because you will have a paper to look at, which we gave. Okay,
Yeah.
so there are high chances that when you appear for it, most of the questions will be from the previous semester paper that we gave. So you are in
Okay.
luck because of that. Yeah.
Got it.
Do you have last semester paper?
Who am I asking? Me?
I'm asking Aniru. Do you have
No.
Sam? Actually, I had shared semester once all three paper in group. It's in a photo. If you want, I can resend it.
Yeah, maybe
All six
recently you
pages.
might have joined later. Yeah.
Yeah.
Yeah,
Would be
I
great.
will send now. Just only give me 5 minutes. I will send again. Yeah.
Okay. Thank you.
Okay, and Anirudh, share your email ID on the chat, so then
Yeah,
I'll
I
be able to.
already shared.
You did?
Mm.
Okay, cool. Cool, awesome. So yeah, let's meet tomorrow at 6, and we'll do both. We'll do DSA and object-oriented programming also.
Uh, yeah. Tomorrow I might not be able to join at 6 actually. I have some already one appointment, but I will do the changes in the slides if possible.
Okay, awesome. No problem.
Okay. Thanks.
Thanks, everyone. So it's actually between 6 to 8. So even if you're able to join late, it's fine. This is
Yeah.
for everyone. Even if you're not able to attend the entire 2 hour session, just join it when you're comfortable. Be there for 10 minutes, be there 15 minutes, half an hour, doesn't matter. You never know that 15 minutes you spend might be the question that might be asked in the examination. So, more the merrier. Thanks, everyone. Have a good night.
Thank you. Good
Thank
night.
Bye.
you.
Good night.
Thank you,
Bye.
everyone. Bye